Oh yeah, this is a self-sustaining photovoltaic electric generator. Now in this first picture what we're actually looking at here is the RCM, or the reflective circular magnifying prism, the RCMP should I say. You've got a side-on view in the centre, you've got a sectional view on the left hand side, another sectional view on the right hand side, showing at the top in small and the bottom bigger, showing the light reflecting through it and being amplified out of it. Okay, now I'm showing you a picture of an LED with a Fresnel 8 reflector behind it. And the Fresnel reflector is the same as a Fresnel lens. There's no real difference to this, it's just saving space inside the light tube basically. And this is the construction of the light tube. These are the two constituent parts of the light tube. Right, now looking inside the light tube, this is the Fresnel lens, how it directs the light and focuses it onto the next lens, whatever lens that would be. You can use whatever lens you want. The rest of the light tube I'm not going to show. I'm just showing the first bit with the LED, the Fresnel lens, and how the light waves come off the LED, hit the Fresnel lens and then get focused onto the next lens and magnified. Down at the edges I'll leave an air gap. As you can see there, it says air gap, or another central reflector. This is because I'm going to be using the RPMC. Let's move on to the RPMC picture. Here we are looking at the RPMCs, the reflective prism magnifying blah 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 whatever. And what we see here is how the light waves are coming off the LED and hitting the reflective surface, which is lining the tunnel, which the prisms are basically either attached to or very very close to, and how the light enters the prism or reflects off the reflector, because you don't have to use a prism, you can just use the reflective surface reflected into the magnifiers, and then the light's being magnified onto the next magnifying lens, which again I'm not showing you the whole lens tube here, I'm just showing you the initial part of the lens tube here. So I think you get the general gist of it. I'm just trying to focus all the light into the centre. I haven't depicted any of these pictures, but you see the cyan coloured lines underneath or on top, which part you're looking at of the lenses here. Well, that's depicting a reflective layer, which I haven't put in the picture here. Right, moving on. What we're looking at here now is quite clearly an octagon, or a hexagon, whatever you want to call it. I think it's an octagon. It's got 8 sides to it, and it's showing you with one light tube it will have 8 light tubes on it. And the reason it has 8 light tubes on it is because you'll see a 40-degree angle coming out of the last lens, which is in, well, this is plate glass, like it's not octagon shaped plate glass mirror, which is not only coated on the back so you can see your face in it like a mirror, but it's also coated on the sides as well. As well as being coated on the sides, at the points won't really be there. The points will be polished off into the lens, and the light tube will be affixed to the lens, so that will be the final lens. And the idea of the 40-degree angle is so it goes to the central point of the opposite lens, and that sorry, not the central point of the opposite lens, the central point to the opposite and adjacent lens. And what this does at 40 degrees is you get an overlapping wavelength in the light, which creates a lens inside the light waves as well. So you not only get amplified lensed light coming into the reflective mirror plate glass device, it's also lenses inside it as well, which increases the volume of light, or the output of the light as well. I don't know how you want to say it. I don't care for your terminology. One of those that it does the overlapping light waves multiply each other and create lenses inside there, so you'll get hot spots. The back of the mirror is shaped as well to reflect the light outwards. So basically what you're looking at here is, like, you get the flat speakers. Well, this is like a flat lamp or a flat torch. This is a torch condensed into a flat plate of glass. And the reason why I'm showing you how to make a torch in a flat plate of glass is apparent when we come to this next picture. Now the next picture shows you the light tube on the left hand side, which is just a box, and then the top black oblong box is quite clearly the reflecting flat torch. I think we'll just call it a flat torch now, yeah. And then underneath it is the photovoltaic cells. Now at this point now, if we go back to another picture, I've got an LED with a Fresnel lens. So I've got an LED which takes 3 volts, 4.5 volts, some of them do, and milliamps to power up. Then I've magnified the light using these lenses and magnifying glasses, and then I've focused all that light into this flat torch, and then I've magnified all that light onto some solar cells. Now high quality solar cells are good in sunlight, but if you use just a Fresnel lens on top of it, they become even more productive. Now if you use this on top of it, it's just as good as being outside on a sunny day, I think, if not better, with a Fresnel lens on top. But instead of having to rely on the sun to provide you the power for the solar panel, now you've got this flat torch. We're calling it a flat torch, remember, at the moment. That's not the technical name I've got for it. And then it becomes self-sustaining, because you're using 8 LEDs which are using 4.5 volts maximum. You might be using up to an amp for 8 of them, so 4.5 volts and an amp. Now a solar panel, 4.5 volts and 1 amp, is very small, and these flat torches can be made with 8 LEDs to power up any size solar panel you want. So let's say you get a 12 volt 100 watt, so you get 12 volt 200 watt solar panel, take all the bits and bobs out of it, make it, how I would say, is take the glass off the front of it and put my flat torch instead of glass. Yeah, so it's a lot more compact, and arrange the cells in a lot more convenient manner than what they are. And the amount of heat that's generated inside this, because the amount of magnification, is quite dangerous. So it needs a cooling system. So it needs a liquid cooling system inside it. So it's got to have some kind of either copper conduits or something like that, and taking that out to radiate it on the outside. Or you could have a hot water tank. Obviously, if you got it inside your house or something like that, you could have a hot water tank. Or if it's inside your car, you could use it for a heater inside the car, blowing hot water. Or you could just radiate it, so send it on a radiator and blow a fan through it. And of course, it produces that much electricity, it can power its own LEDs and a cooling fan for a radiator as well, plus give you extra electricity. And that is a self-sustaining flat torch photovoltaic generator. You could